Let's look at a harder question. Suppose that 2x equals to 3 capital F of x plus the integral from 0 to 2x, x plus 1 e to the 2t over 1 plus t squared dt, and we need to find the f prime of 0. Before I start, I can see that, well, there are two options. I can either do differentiation implicitly, or I can isolate this f of x first before I do anything. In this case, I'm gonna do implicit differentiation first. And before we start, just notice that this integral is a bit special because, well, we are integrating with respect to t. I'm gonna highlight this part. We're integrating with respect to t here. However, we also have x inside of the integral, and this x plus 1 is basically a constant here. If we talk about the integral itself, you can treat it as a constant, but in the whole thing, when you take the derivative, because we're taking derivative with respect to x, it's not really a constant. So to make our life easier, I'm gonna take it out first, treat it as x plus 1, multiply by this integral without the x plus 1 part, so that it is easier for me, because, well, you're not really integrating with respect to x, but you are differentiating with respect to x. So that's my first step before I do any implicit differentiation. Now I'm gonna differentiate it on both sides with respect to x. That's gonna be 2 equals to 3 f prime of x plus, now we need to be careful because this is a function of x, and this integral itself is also technically a function of x. That means you are differentiating a product of two functions. That means we need to use product rule. That's gonna be 1 times 0 to 2x e to the 2t over 1 plus t squared dt plus x plus 1 times the derivative of this part. And to differentiate this, we need to use fundamental theorem of calculus. So that is, you need to sub this back into this function. Wherever there is t, you replace it with 4x and then multiply by the derivative of 4x. So that's gonna be e to the 2 times t is 4x, over 1 plus t, again t is 4x, so 4x squared, and then multiply by the derivative 4x, which is 4. Now, I basically differentiated both sides of the equation already, and remember, we need to look for f prime of 0, so now I can plug in x equal to 0 and see what happens. In this case, you can simplify it first, but I don't really want to simplify it because it looks quite ugly, so I'm going to do it directly. So let's sub in x equals to 0, because I already differentiated everything. That's going to be 2 equals to 3 f prime of 0 plus, even though this integral looks ugly, but you can tell that it's from 0 to 0 once you plug in x equals to 0. And we know that the integral from a to a is going to be 0. So this ugly integral here, the whole thing, is going to be 0. Plus, 0 plus 1 is 1, so plus 1 times this fraction, that's going to be e to the power of 0 over 1 plus 0 times 4. Simplify even more. 2 equals to 3 f prime of 0 plus 0 plus e to the 0 is 1, so that's going to be 4. And now I can isolate f prime of 0 to find the final results. So f prime of 0 is going to be, you can move this to the other side, that's going to be negative 2 over 3. And that's my final result. So recall this whole process, I want to mention a few parts that you might make a mistake. The first thing is, whenever we look for f prime of something with a value inside, we should always differentiate first and then sub in value. Because some people would sub in this value first, which you're gonna change the whole thing. You're gonna change the whole function, and you take derivative that's gonna give you the round result. So always remember, you need to differentiate first and then sub in the value after you finish the differentiation part. The next part is, well, remember, if you are integrating with respect to t and you have x inside, or integrating with respect to another variable, you have a different variable inside, then this is not going to be integrated, you treat it as a constant. However, in this case, life is slightly harder because we're differentiating with respect to x, so it's not really a constant way to differentiation. That is why I took it out. I took it out of this integral, and that's gonna be a product, and recall product rule. So product rule is applied here, right here, and the rest is just fundamental theorem of calculus. And well, we used one of the property here as well. If you go from a to a, b to b, just if the upper bound and a lower bound of the definite integral is the same, then that's gonna be 0. And that's the end of the question.